We're going to go ahead and get started. As I mentioned, my name is Gabriel Cardona. I am a developer evangelist from Avalanche, and today's presentation is going to be an introduction to the Avalanche platform, followed by a demo. So we're going to talk about a few of the things that make Avalanche so special. So we're going to talk about Avalanche Consensus. We're going to talk about subnets, virtual machines, and then I'm going to actually do a demo. So let's hope the demo gods are with me today, where I'm going to deploy a local 5-node network and deploy a smart contract to it. And then I'm actually going to launch 2 subnets. One of them is going to be an instance of the Ethereum virtual machine, and I'll launch a smart contract, and then I'll launch a different type of virtual machine to just kind of demo that Avalanche has different types of virtual machines. We're not just another instance of the Ethereum virtual machine, which I believe is a misunderstanding that some people have. So let's go ahead and get started. What is Avalanche? So Avalanche is a global financial network for the issuing and trading of all digital goods. So we enable potentially millions of validators to process thousands of transactions per second with sub-second immutable and irreversible finality. And we've paired this extremely high throughput, fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. And we accomplish this through what we call subnets or subnetworks. So subnets or subnetworks allow anybody anywhere to spin up a tailor-made network with a custom virtual machine and complex validator rule sets. And so the way to think about Avalanche is really a network of networks. It is like a platform with many different platforms where we envision thousands and thousands of these public and private subnets all emerging into this global marketplace that we call the Internet of Finance. And so very quickly, I want to give a brief history on the evolution of the blockchain revolution. So I suspect that what's on these next few slides is not going to be, radical news to most of the people sitting in this room, but I've found that it often helps to get on the same page, and then also to really appreciate where you're going. It helps if you understand where you're coming from. And so very briefly, let's go over the evolution of the blockchain revolution as I see it. So Bitcoin is blockchain 1.0. And, in the beginning was Bitcoin, and Bitcoin was good. And, Bitcoin proved to the world that there was this need for this decentralized and robust payment network. And I've been into cryptocurrency for a very, very long time. I actually got my very first Bitcoin in 2011. If you guys are familiar with faucets, we have a faucet for the Avalanche network, and most crypto networks have a faucet. It's a website you go to and you put in your address, and they drip you a little bit of crypto to help on-ramp you into their network. The very, very first faucet ever was created by Gavin Andresen. Gavin Andresen is the guy who was working with Satoshi in the very, very beginning. So, Satoshi, when Satoshi stepped away, actually, he gave the keys to the kingdom to Gavin. So Gavin spun up the very first faucet, and he was giving out 5 Bitcoins for each drip. And so in 2011, I got my first 5 Bitcoins for free from this faucet. And I mentioned that to sort of say, I remember when Bitcoin's whole mission was to be peer-to-peer electronic cash for the world. And, it didn't ultimately end up being that. It's much more akin to digital gold these days. And, I was salty about that for a long time, but not so much anymore, because now I kind of appreciate Bitcoin as having matured into this hedge against inflation for mom and pop investors. And I think that's a super critical role that it fills. There's other cryptos that do that. You can do that with Avax as well. But Bitcoin was really amazing. It changed a lot of people's lives. It changed my life for sure in a big way. And but it's not perfect, obviously, or we wouldn't be having this conference today. And so there are a few things that Bitcoin does not do so great. So number one is Bitcoin is slow. So it only does a handful of transactions per second. I'm familiar with the Lightning Network. Somebody out there is probably saying, but what about the Lightning Network? For this, this presentation, I'm talking about the layer 1 Bitcoin network. And it only does a handful of transactions per second. and it takes about an hour before you're confident. It takes 6 blocks. Each block is around 10 minutes. It takes about an hour before you can be confident that your transaction is not going to be reorged out from under you. So there's this thing called a reorg attack, where in Bitcoin, you're stacking blocks on top of each other. That's why you have this idea of a blockchain. And if somebody can come along with enough hash power, they can swap out the blocks from under you and create a new branch. And then because of the way the Bitcoin works, the tree with the longest branch is the authoritative branch, if you will. They can basically reorg your transaction out from under you. And the Bitcoin core team suggests 6 blocks, which is an hour. And so, if you're like a merchant and you're doing point of sale stuff, having people wait an hour before you can be confident that the transaction has settled it's pretty bad. And so, it's slow. It takes a long time to settle. It's not lightweight or green. So, a lot of people have heard that Bitcoin burns more energy every single day than some nation states. And you often see headlines that say, crypto is even worse for the environment than you thought. And that's what they're talking about, is that Bitcoin burns more energy than some nation states. But for what it's worth, I'll actually side on the side of the Bitcoin team here. I don't think that's a long-term problem. Basically, every single hour, enough energy falls on the earth in the form of sunlight to meet 100% of our needs with renewable and nuclear and fossil fuels. Every single hour, we get enough for the full day. So, if we had systems that could harvest this energy and store it and transport it, then really we have, as much energy as we need. I'm sure we'll figure out ways to use it, but so to me, the fact that Bitcoin burns a lot of energy isn't a huge deal, because within our lifetimes, we're going to harvest and tap into the power of the sun. So in the long term, not a big problem. In the short term, it is a problem because it's bad optics, because like what I just said, people can put out blog posts that say crypto is bad for the environment because Bitcoin burns a bunch of energy. So that's a problem. Bitcoin doesn't have really smart contracts or a scripting language. Let me roll that back. It does have a scripting language called Script, but it's stack-based, and it feels very much like you're writing in Forth from maybe like the 60s or the 70s, if you're familiar with that programming language. It's very, very awkward and cumbersome. And if you've come of age in the modern era with you're used to, Python and JavaScript and Golang and that kind of Swift, that kind of stuff, Bitcoin's scripting language is incredibly awkward and cumbersome. And so that's a downside. And then it doesn't really have native tokens. Believe it or not, Bitcoin doesn't have tokens. It has this op code called op return. So the way script works is you stack op commands. And so you have to push them onto a stack and pop them. It's very, very, very awkward to use. And so there's an opcode called op return, which allows you to write 80 bytes of arbitrary data to the blockchain. And you can encode token creation and issuance and transfer and burning, et cetera, multi-sig, et cetera. You can encode these type of transactions and write them to the blockchain using op return. And then you can get a wallet which can tease out that data and parse it and make sense of it. So you can get tokens. You've seen tokens on Bitcoin, but that's the way they work. They're really a technical hack. They're not native. The Bitcoin virtual machine does not understand them as tokens. And so that's a downside. So, Bitcoin is awesome. It changed everybody's life in a big way. I love it, but it leaves a lot to be desired. And so I always like to close this particular section by just giving a shout out to Satoshi. It's really kind of challenging to even put into scope how much of an impact Satoshi has had, really. If Satoshi was one person, which that's the story we were told, he or she or they had a really, really radical impact. And so I always like to say, I hope that they're out there living their best life and that they're happy and healthy and contributing to the next amazing generation of technology. So I just like to give a shout out to Satoshi. So next we have blockchain 2.0. And we view blockchain 2.0 as being Ethereum. So Ethereum is a decentralized application which allows other developers to launch their decentralized apps on top of it in the form of smart contracts. So prior to Ethereum, if you wanted to launch your own decentralized application, you really had to roll your own network. So that was the problem, not creating the idea for the dApp, but creating your own network. And so this led to a very bespoke environment where very few dApps were able to get the network effects required to tip and go mainstream. And so by enabling developers to launch their own dApps on the top of it in the form of smart contracts, Ethereum just led to a huge, huge, huge network effect. And that was their ultimate win. And so they led to a big wave of innovation around tokenomics, initial coin offerings, ICOs, non-fungible tokens or NFTs, decentralized finance or DeFi, yield farming, prediction markets, distributed autonomous organizations or DAOs, and so much more. I am a huge fan of Vitalik. I think he's remotely attending this conference. Obviously, there was a team around Vitalik that created Ethereum, and I'm giving recognition to the team. But for what it's worth, just sort of Vitalik as an individual, I'm a big fan of Vitalik, and I always say that his best days are probably still ahead of him. If you think about it, he's a young man, he's in his 30s, and the analogy I like to use is Linus Torvalds, the guy who created Linux. So, he created Linux, and that was his round one. And then for round two, he created Git. And if you ever use Git, you know how transformative Git is. And that's pretty rad that he did both of those. And so I always wonder sometimes, what Vitalik's chapter 2 is going to be after he, gets Ethereum where he wants to get it. What's he going to do for round 2? Because he's still a young dude. So I'm a big fan of Vitalik. So that's what we think of as blockchain 2.0. And now we think of Avalanche as blockchain 3.0 technology. So, it's really that big of a deal. We think of it as a huge paradigm shift. And similar to blockchain 1.0 and blockchain 2.0, Avalanche introduces a handful of new paradigms, which we're going to go over today. So we're going to talk about Avalanche Consensus. So Avalanche Consensus is the third major paradigm shift in the field of the computer science field of consensus over 40 years or so. It's a really big deal. It's sort of underspoken because it's very heavy on the computer science, but it's a really big deal. We also talk about how Avalanche enables developers to spin up their own tailor-made network. So that's network of networks. We talk about custom virtual machines. And then lastly, we're going to talk about subnets or subnetworks. So let's talk about Avalanche Consensus. What is consensus? If you work in the blockchain space or if you attend conferences like this, if you work in the blockchain space, you've probably heard the word consensus a dozen times every single day. So what exactly is consensus? So consensus is the process by which a series of individuals or computers come into agreement on a decision. So it's really that simple. How do you get people to agree on something? That's what consensus is. And it's a very rich field of computer science. It goes back probably 40 years or so. And there have been really 3 large paradigm shifts in the field of computer science as we see them. And you can see this nice little comparison chart. Hopefully you guys can see it in the audience. I'll make these slides, of course, available at the end if anybody cares to dig in. So as I mentioned, Avalanche Consensus is the third major paradigm shift in the field of consensus going back to the late 70s and early 80s. And the first paradigm shift is what we call classical consensus. It's on the left in the columns there. And classical consensus is, it has extremely high throughput and it has fast finality. It's very green and lightweight, but it's not decentralized and it's not robust and decentralized, and it performs poorly in adversarial conditions. And around 2008, 2009, when Satoshi Nakamoto released Bitcoin, the world was introduced to Nakamoto Consensus. And that was a huge leap forward. I believe the word consensus is only in the white paper one time. I think it even might be like the last paragraph. It's definitely underplayed, but in my opinion, it's sort of at the heart of why industry professionals, computer scientists, teachers at colleges, hackers, the reason they all sort of got turned on by Bitcoin in the beginning was because Nakamoto Consensus is genuinely a big leap forward in the field of computer science. And so Nakamoto Consensus, of course, it's very scalable and robust. It's very decentralized, but it's not lightweight. It has all of the downsides I just mentioned earlier, right? It's not lightweight. It burns more energy than some nation states. And it performs okay in adversarial conditions up to the famous 51% attack. In 2019, a pseudonymous group known as Team Rocket released a white paper on the Interplanetary File System, the IPFS, describing the third major paradigm shift in the field of consensus. And this new form of consensus is known as Avalanche. And so Avalanche Consensus is really the perfect storm of features between Nakamoto Consensus and classical consensus. Really, we get the best of both worlds. So it's very scalable and robust. It's very, very decentralized. I don't know what the exact number is today, but recently there were 1,500 full block and vertex producing validators on our mainnet. In theory, Avalanche Consensus can support millions of validators. Of course, we've not proven that yet on the main network, but in the future, our software will be able to run on Internet of Things devices. It used to be able to back in the day. Since then, because of some architectural decisions we've made, it can no longer run on like a Raspberry Pi, but it did back in the day, and it will be in the future. And so in the future, there will be millions and millions of validators. It's really, really exciting. Avalanche Consensus has extremely low latency. So this is the one I think might be the most exciting, but it's sort of like, it's exciting from a technical perspective. So if you get it on that perspective, you get why it's exciting. So Avalanche has sub-second, immutable, and irreversible finality. So you remember I said Nakamoto Consensus with Bitcoin takes an hour to be sure your transaction is settled. In Avalanche, you get that in about a third of a second. So literally the blink of a human eye and your transaction has settled immutable and irreversibly for all time. There is no such thing as a reorg attack on Avalanche. That's not a concept that we have. And so that's really exciting. Remember, I was just saying if you're a merchant, you're not really used to having people say, we need to wait an hour before your transaction is settled. Well, in Avalanche, you don't have to do that because by the time they've swiped their card and the transaction goes beep, beep, it's already settled on the blockchain for all time. And so that's really, really exciting. Sub-second, immutable, and irreversible finality. It's super lightweight, so you can run Avalanche Go on a VPS droplet on the cloud, on a Macintosh, on a PC. As I mentioned, it used to be able to run on Internet of Things devices. It will be able to again in the future. You can run it on the cloud, obviously. And it's parameterizable, so it performs very, very well in adversarial conditions. So I have a nice little demo here. Sometimes it works and sometimes it does not. This is just a little video. So really quickly, technically, Avalanche is a metastable consensus protocol inspired by epidemic protocols and gossip networks. And the process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling. And so here is this nice little demo that was created by Ted Yin. Ted Yin is one of the co-founders at Ava Labs. Prior to being at Ava Labs, Ted helped create Hot Stuff. And Hot Stuff is the classical consensus protocol, which is behind Facebook's Libra network, or Diem. You guys may have heard Facebook was launching their own crypto a couple years ago. It was called Libra. They rebranded it. It's called Diem now. It has a classical consensus protocol called Hot Stuff, which was created by our co-founder, Ted. So after Ted created Hot Stuff, he helped create Avalanche, which I think is pretty rad. So he created this demo. So what we're seeing here is all of the squares represent different nodes, and the colors of each square represent the current proposal. So is this transaction blue or is this transaction orange? And so briefly, it's worth mentioning that Avalanche Consensus can handle non-binary decisions. So in theory, I could hand this and say, give me 3 out of 5 or something like that. But for the sake of blockchain transactions, usually what we see is, binary decisions, accepted or not accepted. So that's the reason this demo has just 2 colors, orange and blue. But it's worth noting, you can do multiple. The darkness of the color shows the node's conviction of that proposal. So does the node really believe it's blue, or does it kind of believe it's blue? It shows how dark it is. And then when I click start, each node is going to be, it will begin repeatedly and randomly sampling its peers, and it will change its own conviction and color based upon the responses it gets from its peers. And so check this out. It only takes a couple of rounds of sampling, and the entire set will actually tip an avalanche into consensus. I want to play that one more time because I like watching it. It's pretty. So you can see it only takes a couple rounds of sampling, and then the entire set will just tip and avalanche into consensus. It's pretty cool to watch. So hopefully that gives you a bit of an intuition around how Avalanche Consensus works. It's just repeated random subsampling. So now let's talk about network of networks. Excuse me. So as I mentioned before, Avalanche is different than the traditional networks that are sort of in the top 5 of today's world. Let's think about Bitcoin and Ethereum. Pardon me. Avalanche is different in the sense that Bitcoin just has one virtual machine and one set of validators or miners, right? There's the Bitcoin virtual machine and the miners. There's the Ethereum virtual machine and the miners. Avalanche is different than that. Avalanche is a network of networks where you can spin up your own, what is effectively a layer 1 network, and then you can either have native communication or have bridge type communication between the different networks, which leads to compound network effects, and it's pretty exciting. I have this really great slide that will give you an intuition about this. You can see at the bottom right there, it says CryptoSec. I'd like to give a shout out to the great CryptoSec, who is a really, really great thinker in the blockchain space. Not just Avalanche, but all of the different blockchains. Go check out, I don't know their gender actually, so go check he or she or them out. At the bottom right, you can see their Twitter handle and their Medium handle. Go follow them. A really, really great thinker in the blockchain space. So to help visualize the way Avalanche works as a network of networks, I have this really great slide here. And here you can see that the gray oval represents the Avalanche network. And within the network are many different subnetworks or subnets, which are represented by the different circles. And in each of those subnets are green squares, which represent the different virtual machines or blockchains that are running on those subnets. And then the lines between the different subnets show the ability to move assets and users and make smart contract calls between the different subnets and between the different virtual machines on those subnets. And then at the very top, you can see Bitcoin and Ethereum and Cosmos with lines that represent the ability to bridge assets from those other networks into the Avalanche network. So currently, if you go to bridge.avox.network, you can bridge assets between Ethereum and Avalanche and Bitcoin and Avalanche. So these numbers are old. I'm sure that the number is much greater than this. But when I pulled these numbers, it was at least 2 or 3 months ago. It was already 50 billion with a B, $50 billion in ERC20 tokens had bridged between Ethereum and Avalanche over a total of 300,000 transactions. So I'm sure it's now 500,000 transactions and 75 billion. I'm sure it is because it's been a few months. And that's just between Ethereum and Avalanche. You can also bridge between Bitcoin and Avalanche. So if you have Bitcoin, BTC today, and you want to partake in DeFi, you can bridge your Bitcoin from Bitcoin into Avalanche and then use your Bitcoin in DeFi smart contracts in Avalanche. It's pretty amazing. And so I often say that Avalanche's subnet architecture is primed for compound network effects. And so what do I mean when I say that? So most everybody has heard of network effects, right? Technically, network effects are known as Metcalfe's law. And so Metcalfe's law says that a network's value is proportional to the number of nodes. I'm sorry, let me repeat that. Metcalfe's law says that a network's value is proportional to the square of the number of nodes in a network. So for example, if a network has 10 nodes, its inherent value is 100, right? 10 times 10 equals 100. So in other words, a product or a service gains additional value as more people use it. And I think there's a couple good examples of network effects. One of them is like the telephone service. So if only one person has a telephone, it's not very valuable. For every additional person that plugs into the telephone network, the entire network becomes more valuable for every other person. But I think sort of the canonical example of the network effect is money. And we saw this with Bitcoin coming online and every other cryptocurrency that comes online and slowly becomes worth value. If only one person accepts Bitcoin, when Satoshi created it, before he sent Hal Finney the famous 50 Bitcoins on like block 10 or something, Bitcoin wasn't worth anything. But for every additional person that accepted Bitcoin, it became worth more to every other person because ultimately you could spend it or receive it for goods and services for more and more and more different things. And so it's been really cool to see the network effect of cryptocurrency happen. And again, that's basic Metcalfe's law, which is network effect. But I often say that Avalanche's subnet architecture is primed for compound network effects. So what are compound network effects? So the compound network effects are known as Reed's law. So Metcalfe's law is network effects. Compound network effects are Reed's law. And Reed's law states that the utility of large networks, particularly social networks, can scale exponentially with the size of the network as the number of possible subgroups grows much more rapidly than either the number of participants or the number of possible pair connections. So even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. And so compound network effects are like network effects but amplified. And so we're able to see this in Avalanche because, for example, when you launch your own instance of the EVM, a subnet EVM, which is what I'm going to demo here in a second, today, if you are live on Ethereum, you're competing against a bunch of different apps, right? So you've got to compete against all these other dApps with their users and for the throughput, for the finality. You're competing for the resources of those validators, and so therefore the prices of the gas is going up or down. Whenever you launch on a subnet, we have this paradigm we're calling application-specific blockchains. So you launch your own instance of the EVM, and you launch your own dApp or handful of dApps which make up your dApp, and you're the only dApp that's running on your subnet. And so you don't have to compete against anybody for the throughput and the finality, so the fees are very, very low. But you may say, all of the users are on the primary subnet. How am I going to get them on my subnet? Well, today you'll use bridge technology. In the future, you'll be able to use native smart contract calls. But the cool thing about Avalanche is that you can immediately leverage all of the resources that are on our primary subnet. So the billions of dollars in total value locked, the hundreds of thousands of active users every day playing all of these different games and playing, participating in DeFi. You immediately have access to them on your subnet. And so we have these compound network effects, and we're seeing these subnets launch and just go huge immediately. I forget the exact numbers, but DeFi Kingdom and Krabata, both of them launched. They were dApps on our C chain and blew up and launched their own subnet. And today they have subnets that are doing, I wish I knew the exact number off the top of my head. I could find it when I go to the browser. But like dozens and dozens of transactions per second, just one single dApp. They've launched a subnet which has hundreds of millions and at one point billions of dollars in total value locked. It's pretty cool, and they're able to leverage the network effects of the different subnets. And so Avalanche's subnet architecture is really primed for these compound network effects. It's really, there's nothing else like it. It's very, very cool. So next we have virtual machines. And so, one second, please. Water. Everybody take a drink right now. Virtual machines. So a virtual machine defines the application level logic of your blockchain. And in technical terms, it's a state machine, basically. So you can think about it as the blockchain state, a state transition function, it has transactions, and then it has an API, the JSON RPC. It has an API through which users can interact with the blockchain. And every single blockchain that runs on the Avalanche network is an instance of a virtual machine, every one. So if you see a blockchain on Avalanche, is it a virtual machine? Yeah, every single blockchain on Avalanche is a virtual machine, every one. So the way to think about it is it's like a class in object-oriented programming. So if you're familiar with a class is a template that you can instantiate as many different objects as you want. And each one of these objects, though they all are derived from a common template, they're all unique entities with their own state. And so we have that very similar paradigm in Avalanche where a blockchain is an instance of a virtual machine. And a virtual machine is a template from which you can instantiate as many blockchains as you want. And each one of these blockchains, though they have all derived from a common template, a common virtual machine, they're all unique and separate entities with their own state. And that's the way to think about it. A virtual machine is to a class as an object is to a blockchain. And so as a developer, when you write your virtual machine, you don't need to concern yourself with any of the lower level logic like networking, consensus, the data structures of your blockchain. You don't need to do any of that stuff. Avalanche does all of that for you behind the scenes. And you can just focus on the special sauce, which makes your dApp special. So why virtual machines? So at first, blockchain networks like Bitcoin and Ethereum, they only have one virtual machine, and it's predefined. It has a static set of functionality. It's very rigid, and the monolithic design limits what blockchain-based applications you can actually create. So when you go to create smart contracts on Ethereum, you're actually kind of blocked in by what you can creatively. The creative space from which you can pull your solutions out of is somewhat boxed in by the APIs that Ethereum presents you, obviously. And so, again, people who want to create custom decentralized apps have to create their own entirely new blockchain network from scratch. And this takes a bunch of effort and time, obviously. It offers limited security. Generally, it results in a very bespoke environment where few of these networks were able to achieve network effect, tip, and go mainstream. And so again, the big win with Ethereum was allowing developers to launch their own applications on top of it in the form of a smart contract, which just led to this absolute massive network effect, which I spoke about earlier. So the Ethereum virtual machine has low performance. It imposes restrictions on smart contract developers, and then Solidity and Viper and the other languages which are available for writing Ethereum smart contracts are unfamiliar to most programmers. So, if you spend all day long working with Golang and TypeScript or Python, and then you have to focus just this one single job you do with Solidity, it's just not a great workflow. You know what I mean? It's not the ideal workflow. Ideally, you would be using the same set of tools that you use the rest of the day to do your blockchain work. And so Avalanche's virtual machines make it easy to define blockchain-based applications. And then rather than new and limited languages like Solidity, you can write your virtual machines in Golang. And then also, thanks to gRPC API, you can write your virtual machine in any language which can implement this gRPC API. And so your blockchain can run as a separate process from the Avalanche Go process, and it can communicate with Avalanche Go over gRPC. And this is enabled by RPC chain VM. So we have a custom VM that uses Go plugin and wraps another virtual machine implementation. And this is the way our C-chain works right now. So our C-chain is a core ETH virtual machine, which is wrapped by RPC chain VM and then runs in a separate process from Avalanche Go. It's pretty cool. And next we have subnets. So a subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. Let me repeat that. A subnet is a dynamic set of validators, working together to achieve consensus on the state of a set of blockchains. And each blockchain is validated by exactly one subnet, and a subnet can validate many different blockchains, and then one node can be a member of many different blockchains, or many different subnets, sorry. So Avalanche is very, very heterogeneous. It's very rich and diverse in character. There's a lot going on, and so if you kind of want to visualize it like this, we'll sort of start in the middle and we'll work our way out. So a virtual machine is the application level logic of your blockchain, right? So we're starting there, a virtual machine. It's like a class in object-oriented programming. It's the application level logic of your blockchain. It's your dApp, it's your virtual machine. It can be instantiated into many different blockchains. Some of them are private, some of them are public. Each blockchain is then validated by exactly one subnet. And a subnet can be a spectrum from totally private and locked down to completely open and permissionless, which we just launched yesterday when we launched our new 1.9 Avalanche Go. We're calling it I believe we're calling it Elastic Subnets, but it's the permissionless subnet thing we've been talking about is now live on our network as of yesterday. And so a node can be a member of many different subnets, validating many different blockchains, including many instances of the same virtual machine, some public and some private. So there's a lot going on there. Avalanche is very, very heterogeneous, is very, very rich, and it has it's a multifaceted jewel. You can sort of look at it from many, many different angles. Some cool things about subnets is they manage their own membership. So they can actually require that constituent validators have certain properties, and this can be useful. So for example, regulatory compliance. Avalanche's subnet architecture makes regulatory compliance manageable. Regulatory compliance is a really, really big deal. It's one of the big chapters of the blockchain which we are living under currently, and which is going to become more and more important going forward. And there's going to be many, many, many different regulatory frameworks that happen all around the world. It's going to be a wild, wild journey to go through together. And out of all of the different blockchain networks, and I've worked with many of them, Avalanche's subnet architecture really does make regulatory compliance manageable because we give you all of these levers that you can pull. So for example, you can say, every validator that's in my subnet has to be located in a certain legal jurisdiction or country. Every single validator that's a member of my subnet has to meet certain KYC AML requirements. Every single validator which is in my subnet has to hold a certain license. Now, these are not mandatory, so before somebody hears that and says, wow, you've got to have a license to use Avalanche, no, you don't, because we have a whole spectrum of completely permissionless to completely permissioned. And that's why I was saying Avalanche does so well in the regulatory compliance space, because we allow you to do whatever you want. So if you want to be super locked down, you can do that. If you want to build the next Bitcoin or Ethereum and be completely wide open, you can do that as well. And that's very, very cool in my opinion. We also have support for private blockchains. You can create a subnet where only certain predefined validators can join. And so you can basically create a private subnet where the contents of the blockchains are only visible to the validators which you have whitelisted. So this is ideal for organizations that are interested in keeping their information private. We also have separation of concerns. So in a network, in a heterogeneous network like I described above, some validators will only want to validate certain blockchains because they simply are not interested in the contents of these other blockchains. And so the subnet model allows validators to only concern themselves with blockchains that they care about. This reduces the burden on validators. We also have application-specific requirements. Different blockchain-based applications can require validators to have certain properties. Suppose there is an application that requires large amounts of RAM, large amounts of CPU power. A subnet can require that validators meet certain hardware requirements so that the application doesn't suffer from low performance due to slow validators. So validators can have hardware requirements. And then we also have the primary subnet. So this is what went live when Avalanche went live in August of 2020. So this is our primary subnet. And it consists of 3 blockchains. Every single one of the prerequisites, if you want to launch your own subnet on Avalanche, is you have to validate the primary subnet. So that's one of the hard rules. And so that's why I said today there's like 1,500-ish, I don't know the exact number, but there was 1,500 at one point, full block and vertex producing validators on the Avalanche primary subnet. And as I mentioned, it has 3 virtual machines running as blockchains. You can see them there in the middle. In the very middle, we have the X chain. And so it is an instance of the Avalanche virtual machine. So really quick, some computer science fundamentals here. There are different data structures for blockchains. There are what is called a DAG, a directed acyclic graph, and it has what's known as partial ordering. And then there's what's known as a linear chain. It has total ordering, and they both have certain attributes, and they're good for certain things. So we offer both of them, of course. So our X chain is a DAG, a directed acyclic graph. It's parallelizable, it's prunable, it has extremely high throughput, 4,500 transactions per second, sub-second immutable irreversible finality. It has what are called feature extensions, so you can extend the functionality by plugging in feature extensions. There are 3 feature extensions. Today we have SecP 256K1 curve on ECDSA key pair variable and fixed cap assets, so you can launch your own tokens and either mint more of them or have it be a fixed cap asset. You can create NFTs, so these are not ERC 721 or ERC 1155 compatible. These are our own thing, and they're more like a collectible type model. You can also what's called properties, so it allows you to create key value stores. You can add key values to different addresses. So this is how I was saying you could, for example, say every single address in my subnet has to have a certain attached license. You would do that through properties. And then also you can extend it, so you could add Schnorr signatures or BLS signatures or whatever you want. So that's very exciting. That's our X-chain. It has what's called UTXO. So if you're familiar with Bitcoin and Ethereum, you know that Ethereum has an account. You have one address you use over and over and over. Bitcoin has what's called UTXO, unspent transaction output, and you generate a new address for every single transaction. We have both, and you can mix and match. So in the middle, we have our X-chain. It's a directed acyclic graph, and it has UTXO. You can create Avalanche native tokens, ants. On the right, we have our C-chain. This is an instance of the Ethereum virtual machine. It's a linear blockchain, and it uses the account-based model. It's good for smart contracts, and it has 100% backwards compatibility with existing Ethereum developer tooling. So if you have Truffle or MetaMask or Remix or any of the, Open Zeppelin, any of the tooling that you would use in any EVM ecosystem, not just Ethereum, but Binance or whatever, all you have to do, sorry, I keep hitting that. All you have to do is add a new network ID for our C-chain, and you can deploy your smart contracts to our network. So that's really cool. And then on the left, we have what's called the P-chain. So this is a linear chain, but it has UTXO. So it kind of is a mix and match of the X-chain and the P-chain. And this is our administration chain. So if you want to add a new validator, if you want to delegate, if you want to spin up a new subnet, if you want to instantiate a blockchain from a virtual machine, you would do that all on our P chain. And then you can see in the middle, there's a red line that connects the 3 circles. And that shows that you can do native, you can move assets between the virtual machines on this one subnet. And so we have an import and an export function that's implemented on each one of those virtual machines. And so you can actually move AVAX. AVAX was issued, it's a fixed cap asset. There will only ever be 720 million AVAX. It was issued on the X chain, and then we swap it over to the C chain, and you can do DeFi with it. And then we also have what's called ARC20. So you can create an Avalanche native token on the X chain, swap it over to the C chain, and wrap it in an ARC20 interface and use it for doing DeFi there as well. And so that's our primary subnet, and that kind of gives you a sense of everything that we offer, from being able to spin up your own subnet, add validators and delegators, be able to issue Avalanche native tokens, be able to swap assets between the different chains. It shows, a UTXO model, it shows an account model, it shows a directed acyclic graph, it shows a linear chain. It's kind of like the breadth and depth of the entire platform are happening all on our primary subnet. And so now I'm actually going to try and give a little demo here. We're going to see, if the gods are with me or not. So the first thing I wanted to do was I wanted to show you this Avalanche network runner. And so if anybody's familiar with Ganache, it's the Ethereum local development environment. So if you're used to developing with Ethereum, then you can spin up a local network using Ganache, and it allows you to basically, test your smart contracts and do all that stuff. This is similar to that, but it's better. And the reason it's better is because Ganache is a simulator. This is a real 5-node network. So you can see here it actually spun up 5 actual instances of Avalanche Go running on my local machine, and then using a config JSON file, I have them set to these particular ports. And so now here you can see it says all nodes are healthy. And if I go over to Postman and make sure I'm checked on the Avalanche local environment, and then call is bootstrapped, you can see it says true. So you can see that I also, if I crack this open and copy the curl command and go to the command line and paste it there, 1 second. So you can see it is bootstrapped there as well. So this fired up a network on my machine. And then now, some things to note are, I'm demoing, so give me 1 second here. I'm going to open up MetaMask. I'm actually going to, I want to reset this account. Let me connect to the Fuji C chain. There we go. And I want to reset this account. So that should do that. And then if I try and connect to the C chain, does it do it? So it does. So a couple things to note are there is an address we call the EWOC address, EWOQ, are the first 4 letters in the base 58 encoded string, basically. We have this key that we call the EWOC key. And in the primary subnets, X chain, P chain, and C chain, on the local network, there are some AVOCs for that account. You can see here is this one. I might need to reset it one more time. Let me do that. Uno momento. Okay. Right. I'm going to have to reconnect to a local network. Give me 1 sec. There we go. Hold up. I want to connect to this. There we go. Now, if I exit this, let me reset the account. Go fire up a local Avalanche network. Give it 1 second. Okay, so if I then ask it, is it healthy? It says not yet. It says it is now. So now if I go and connect here, okay. Okay, so it did work. Sorry, I was being silent there. I was walking through it to make sure it was all working properly. So it did work properly. So let me show you what I just did. So I fired up this local Avalanche network. You can see up here I'm in the Avalanche network runner directory. And then I ran this script. Hopefully you guys can see it. So it's just a go run and then a path to this main.go file. So what's really cool, I told you that the Avalanche network is actually better than Ganache, and it really, really is. You can do all kinds of advanced scripting. So this particular example is just a 5-node staking network. And 5 is sort of our magic number. We recommend whenever you spin up your own local subnet, we recommend having at least 5. So that's what happens in this script if you wanted to like dig into that and see exactly what's happening. But you can do much, much, much more than that. But so that's what's happening here. I fired up a local network. You can see that I then sent a curl request to it, and it said that it was bootstrapped, so it was all good there. So then what I do is I have MetaMask, and I connect it to Remix. And so, for example, right up here, you should be able to see the injected provider coming through MetaMask is network 43112, which is the Avalanche network. And then you can see this address, the OX8DB, is the EWAC address that I had told you about. So if you're familiar with this, if you guys are familiar with this, is like the Hello World dApp for Ethereum. It's storage.sol. It comes preloaded in Remix. So if you ever check out Remix, if you haven't checked out Remix, you should do that. That should be your next step. It's one of the best web apps I've ever seen. I often think, like, imagine if you could show somebody Remix, a web developer from like 2001, right when the bubble popped and everybody thought the web was going to like go away or something crazy. Imagine showing them Remix and explaining the blockchain and all of the web tech which is in this web app. It's really, really mind-blowing. So this dApp is very, very simple. All it does is it allows you to write a number to the blockchain and then read it back from the blockchain. And so the reason I do it is just to kind of, show that everything's working. So really this just kind of demonstrates that I spun up a local Avalanche 5-node network. I then compiled and deployed this Solidity smart contract to our C chain, and then I wrote the number 123 to the blockchain, and I paid some AVAX to do that. And then you can see I called retrieve, and then you can see it reads the number 123 right there back from the blockchain. So that was kind of step one, is just have an awareness around Ganache. If you want to do Ethereum smart contract development on Avalanche, one of the things I have seen many people do is they kind of just skip this local development environment and they go straight to testing on Fuji, which is our test network. To me, that's an anti-pattern, and you should just make it as part of your workflow that you always develop everything first locally, then you move to Fuji, then you move to testnet. You shouldn't skip the local step, but it seems to be so common, and I would suggest you don't do that. Have the discipline to always test in your testing and local environment. So now, let's kill this network, and I want to go over and introduce you to Avalanche CLI. So Avalanche CLI is our command line tool, and it has everything you need to launch a subnet, and you can deploy it locally. You can deploy it on Fuji. You cannot yet deploy it on mainnet, but obviously that's in the works right now. So you can see when I run this Avalanche command, there's really two buckets of functionality here. We have the subnet command and we have the network command. And similar to the previous command where you can spin up a 5-node network, this tool will also spin you up a network using the Avalanche network runner under the hood. So just to kind of show how awesome the Avalanche network runner is, the tool that I just used, it was used to build this, right? You can use it to build great stuff like this. And so now, I want to say, so Avalanche subnet create Avalanche EVM. So now it's asking me which subnet do I want to create, which virtual machine do I want to use. And we have a couple that are pre-baked into the dApp. We have subnet EVM, and then we have, which is an instance of the EVM. So you remember I told you we envision application-specific blockchains. There's this idea about the scalability trilemma, pick two. Well, in our world, we believe in this vision of application-specific blockchains. And so you don't have to compete against other dApps for the resources of your validators because you're the only dApp which is running on your subnet. So that's what subnet EVM is. It's an instance of the Ethereum virtual machine with Snowman Consensus. Snowman Consensus is like a sister protocol to Avalanche Consensus, where Avalanche Consensus is for a DAG. Snowman Consensus is for a linear chain. So it puts in place a hard rule that says there can only be one parent and one child. So now we're going to launch use latest version. You can set fees. You can airdrop to the EWAC address. You can do what are called precompiles. List. So we have what are called stateful precompiles, and these are really rad. So imagine there's something you want to do, and it's too awkward or cumbersome or expensive to do in Solidity. So imagine you want to write like a cryptographic function or something like that. You can do it in what's called a stateful precompile. So you can implement it in Golang, and then Golang it gives you like a smart contract address that you can then plug into your smart contracts and interact with that interface using Solidity, but it's implemented in a different language. It's called a stateful precompile, and we have 4 that are baked into our workflow by default. You can limit which address can send transactions. You can limit which address can call smart contracts. You can have native minting of assets. So if you already have an ERC20 token, such as Circle has USDC, you can launch a USDC subnet and have all of the fees be in USDC. You could either burn it, or you could give it to the validators. You know, it's really up to you. You're launching your own subnet. You can have completely complex validator rule sets and virtual machines. So there really should be a USDC subnet where all of the merchants and apps that use it are on-ramped into USDC and everything is paid for on USDC rails. I think that would be pretty cool. And so now we have this subnet, and I want to say subnet deploy AEVM. So give it 1 second, it's spinning it up. There's a little bit of a workflow where the subnet has to actually whitelist the validators, and the validators have to whitelist the virtual machine ID. So this, behind the hood, this actually kind of stops and restarts, something that you have to do manually. So here we go. So now it's just waiting to make sure it's all happy and healthy. And so now you can see that it just launched a subnet. So we now have a subnet running on my machine, and it's got this RPC call. So now let's do this. So let's add this to MetaMask. So we go back to MetaMask. 1 second. MetaMask. It's hard for me to see in the lights. I apologize. So MetaMask. I want to add a network. So here we have this. It gave me the RPC URL. The network was called AEVM for Avalanche EVM. The network ID was 9099. This is the same as here. So I think that's everything. So now if I save this, so you can see it airdropped those AEVM, which is what I told it to do. So it gave my EWOC key these native tokens. And so now I could send it to myself if I want to do that. Or what I like to do in this demo is I then go over to Remix. So if you remember, Remix and MetaMask are connected. And so up here you can see that the injected provider's network ID is 9099, which is the one I just created. Sure enough, it's got the EWOC key. But it says Ether, but it should be the AEVM token. So now I can come down here and I can delete this deployed contract, and instead, it's already compiled, so I can deploy it. You can see that it's making me pay the fee in AEVM. I'm confirming. I'm trying to see if it went through. Says you have one pending transaction, so I think it's impending. But here in a second, when it goes through, I'll be able to interact with it down here in the same thing. And so then the other one I wanted to show you is, I have 2 minutes. I don't think I'll be able to do it. But here you can see whenever I was firing this up, it gave me the option to do Spaces VM. So what's cool about Spaces VM is everybody's used to the Ethereum virtual machine. Like we all know that paradigm, DeFi, smart contracts. But we think there's going to be so many other paradigms, right? It's just like as different as Bitcoin is to Ethereum, there could be all of these different types of virtual machines, and that's one of the things that we enable. We give you all of this APIs, all of these developer tooling to go create a new type of virtual machine. And we have a couple of different examples. We have Spaces VM and Blob VM. So here, whenever I say Avalanche create subnet spaces VM, it's going to ask me, .avalanche, what is the word? Yeah, there we go. Spaces VM. So it's going to ask me which virtual machine I want to do, and I'll say, use the Spaces VM. And of course, I don't have time. I got 1 minute. But it's a decentralized, authenticated key value store. And you can use EIP 712 signed data to basically store your data on this subnet. So imagine spinning up a subnet, spinning up an instance of the EVM, launching ERC 1155 or ERC 712 NFTs, launching a subnet with the Spaces VM, having a key value store, storing your assets for the NFT on your subnet, and then having your ERC 1155 subnet EVM query your Spaces VM and get your NFT data that way. So you could do that just with this tooling I've shown you here. So that's it. My name is Gabriel Cardona. Thank you so much, everybody. It's really been a pleasure.